This week we'll be working through another virtual lab. You can see how a chemist might use Hess's law of summation to determine the heat of reaction. Today we're going to focus on the pre-lab information, and this is the title of this lab is called Heats of Reaction in Hess's Law, and the lab handout can be found on the class page. So in this lab you are going to be performing two experiments if we were actually doing this in the lab. So the two experiments that you would run would be an experiment with magnesium metal, so the solid form of that, and you would be reacting it with hydrochloric acid, which we know is aqueous, and you would be forming magnesium chloride, also staying in solution, and also forming hydrogen gas as product. So that would be one reaction that you would be performing, and you would be using calorimetry to do that. The second reaction that you would run would be the reaction of magnesium oxide, which is a solid, it's in powder form, and you would be reacting that with hydrochloric acid, and you would be forming magnesium chloride. But instead of hydrogen gas, this is aqueous, sorry about that, but instead of hydrogen gas, because of that oxygen on the magnesium, you would be forming water, and that would be a liquid. So these are the two reactions that you would be running in this lab, and from the data that you will collect, you would determine the heat of reaction and calculate that, so the delta H's or enthalpies. There's also a third reaction that we'll look at, we won't actually run, and that's the reaction that forms water. So H2 gas, oxygen gas, and that forming water. And we would calculate the delta H of reaction for that, but we would use enthalpy of formation values that are found on thermodynamic tables, which are on the class page. So those would be the three reactions that we're going to look at and use Hess's law of summation once we have all the delta H's to determine what the delta H of the overall reaction is in this experiment. So it would be really important for you to read the background section of the lab so that you can understand a little bit better what's going on in the experiment. And I will be explaining things as well, but the background will help you too. So you want to make sure that you download that handout that's on the class page. So like I mentioned before, the experiments are going to be conducted using calorimetry. So we'll be using a coffee cup calorimeter in this experiment. I have a video of this experiment for you to view after we get through the pre-lab. So you'll want to take a look at that because it will give you the procedure basically, so you can see what you would have actually been doing in lab. After we conduct the experiment, we would look at our data, our temperature changes, the specific heat of water, the mass of the hydrochloric acid and the magnesium, the total mass of those reactants, and we would calculate the delta H from that, or the Q value. And then we would use Hess's law of summation to determine the enthalpy for the combustion of magnesium. So it's hard to determine the combustion of magnesium, basically just burning magnesium in a flame. So we can use these three different reactions and use Hess's law of summation to determine what that delta H would be for that final reaction. So it's something that we did in class, very math-based, and rearranging equations to get that final equation, and calculating delta H. So we're doing the same thing here, but you're going to kind of see how a scientist would actually use this information to determine the delta H of a reaction that maybe can't be performed in the lab and easily determine that delta H. so we can use Hess's law to do that. So in this slide, all I've done is brought in those pre-lab questions from your lab handout. And we're just going to work through. I'm going to give you some hints on how to solve, and then you're going to solve them and submit them to the Dropbox. That will be your assignment at the end of this video. So if we look at number 1, it wants you to look in that background section, and it wants you to arrange equations A, B, and C so that they add up to equation 1. So you can see at the bottom of the slide, I have those equations shown. So here's equations A, B, and C, and no delta H's are given here because remember that's what you're going to be solving for in this experiment. So what they would like you to do is to rearrange the equations A, B, and C so that it equals equation 1. So that means rearranging so you can cancel the things that aren't in the final equation. Make sure you have the things that are in the final equation on the correct side. So what we could say about equation A, B, and C, since we don't have delta H's for them, we could just say that this is delta H of A, delta H of B, and delta H of C. And if we rearrange an equation, we want to make sure that we're changing signs for the delta H. So if we're reversing an equation, I should say, you want to make sure you change the sign of delta H. So that's important to remember. If you multiply anything by a factor, you want to multiply the delta H by that factor as well. So work through that, see what you come up with for number 1. And then in number 2, it says use Hess's law to express the heat of reaction. So that means if you had to reverse any of these and the sign changed from a positive to a negative, you're going to write out using the variables in place of actual data. So you'd be looking at writing out the delta H of the reaction or of equation 1 using the delta H of A, the delta H of B, and the delta H of C. Are they added? Is everything just added together? Did one of them, the sign change, and you have to put a negative in? So you're going to be coming up with this equation using variables since you don't have the delta H values. That's something you'll be calculating in the experiment and then using this equation for your post-lab. So take a look at that. See how you do. The assignment's going to just be worth 5 points, but I am going to be giving you feedback if anything's incorrect because the pre-lab questions are some of these answers will be used for your post-lab questions, so I want to make sure that you have them correct when you start. And then number 3, it says to calculate the, you're going to calculate the actual delta H of equation 3, or equation C. So that equation with the formation of water. So you're going to use the thermodynamic table. So let me just write that out here. So you're going to use that thermo table that's on the class page. And remember that the delta H of the reaction is going to be the summation of the delta H's of the products minus the sum of the delta H of the reactants. So you're going to be using that equation to solve for the delta H for equation 3, because or equation C. Equation C is not one that you're going to actually perform in the lab, but it's one that you can look up the data and find what the delta H would be at room temperature at standard state. So that's what you're going to do for number 3. So I hope that was helpful, just to kind of give you a little preview or a couple little hints to help you answer those pre-lab questions. And the last thing is your assignment. And this assignment is going to be due on Tuesday, May 12th, and you're going to complete those pre-lab questions and submit them to the Dropbox. Again, just please make sure you handwrite them. And it doesn't matter to me if you take a picture and submit a picture, or if you put that picture in a PDF, or if you just submit a PDF with your answers. It doesn't matter, but just make sure that they're handwritten. I am going to look them over, correct them, but it is a 5 out of 5 for completion. So please make sure when I submit the assignment back to you that you check to make sure that you have everything correct, because as long as you do it, you're going to get the 5 points, but that doesn't mean that everything is correct, because I'm not grading this. So just an FYI for that. And then you'll be watching, the next thing, task for you to do this week is to watch the video of the actual experiment, and that is on the class page as well. Hope you guys have a great day, and I'll see you in the next video.